So that's your ERD minimum gas price. And again, over on our parameters, we'll find that right here. You might be saying, okay, why here is it in a whole integer number? And then over here we saw it as a fraction, a decimal that's less than 1. When you multiply your gas by this number right here, you'll directly get EGLD. So if you multiply 50,000 by this number right here, you'll get EGLD. Over here, everything, because this is just for being human readable. Smart contracts and everything running on the network doesn't deal with decimal numbers. They don't deal with floating point numbers. They only deal with integers. And so that's why everything over here is in whole integer numbers. Even this gas price modifier, it's in quotes because it's being handled differently. They don't want you to call this as a number. You would call that as a string, as a text value. So you can see that some things are in text value. Some things can be called as actual numbers because that is literally their number. Okay, the next thing we need to look at is the ERD gas price modifier. This is difficult to apply. Things are going on behind the scenes that we can't necessarily track on its face. So they say, generally speaking, the price of gas unit for contract execution is lower than the price of gas unit for movement and data handling due to the price gas modifier for contracts. Okay, and so what that means is the amount, the cost of the gas that you are being charged is going to be lower than the price of gas for a regular transaction and just data handling. So let's do this. Let's go next. Let's look at one of these transactions line by line and see in the transaction details what we see here. And let's go ahead next and run through the network configuration numbers here. Okay, so first line is your hash. We have a successful status, the age. Let's get on down to something relevant. So the first thing to take note of is this transaction fee. It's going to tell you about what it cost you here. And sometimes that will be in relation to the gas used based on a gas price. And sometimes it is not. So in this transaction is also worth noting that whenever I first called this repeat function on this smart contract, I put in this number here. And if you recognize this number, it's because it's the same number right here, the max gas per transaction. So this is the max amount of gas that they're going to let you run a transaction with. And but if you do that, what's interesting is they'll go ahead and say, okay, well, if you want to provide that, I'll take it. And so you're like, okay, whatever, 600 million gas, what does that mean to me? Well, you may want to consider that on anything outside of DevNet, right? 1, 2, 3, 1, 2, 3. Because that comes out to, at only 141 value, at only $141 per EGLD, that comes out to $85. And if you could imagine, if Elrond gets up to $1,400, you're looking at an $850 transaction cost. Ouch, right? Yeah. So you do need to be watchful of your gas price, because just because it doesn't. So in many of these other transactions that we'll look at, the gas limit provided is not equal to the gas used. Rarely is it. So if you try to calculate it out ahead of time, either with that by if it does it automatically, or if you do it you know, with your own math, you can get it to where it's really close, right? Just like this. But it should only use what it needs. Let's run through the numbers on this network config page and define what these are. So ERD chain ID 1, that's your chain ID for the main net. On the next line, we have ERD denomination. So the ERD denomination, let me take you over to a page that's going to help explain what that is. So here in this page, with the title of ELG transfers, they have some examples for calculating your just a simple transaction, right? So in this first part of this example, we have the ERD minimum gas limit being 50,000. So you're going to be adding on top of that. Per byte, we have 1,500, and the ERD gas price, which is this number here. So what is that number? Well, down at this line, we see that it says atoms of EGLD. So this number here is atoms of EGLD. So back to this number, it takes 1 times 10 to the 18th atoms to make up 1 EGLD. Again, since floating point and decimals are not actually used in your smart contracts in numbers given about the network, we have a very large number that represents 1 EGLD. So right down right here, they said, they give you a little example, right? So this number of atoms equals this amount of EGLD. So this bottom line right here, this is for being human readable form. You won't put this in anywhere in a smart contract. Any part of the network will never read in decimals. It's always in integers. And so if you do the calculation, if you multiply this number right here times 1 times 10 to the negative 18th, you will get this number right here. So that's what that means, is how far down an EGLD can be broken down, and also what the number is that represents 1 EGLD. So that's your denomination. Next is your gas per byte. Remember, that is not in atoms, that is in gas units. The gas price modifier, as we described, should be multiplied for the execution of smart contracts. Then the max gas price. This is the maximum amount of gas units you can provide for a transaction. And the minimum gas limit, that's going to be the base fee for your transactions. And the gas price is how many atoms each gas unit cost. And that's all that's relevant for this video on the configuration data numbers. You may be asking yourself, what's the most cost-effective way of performing a number of transactions? Should I use a smart contract, or should I perform individual transactions, calls using Erd.js or ErdPy, or even using multiple transaction methods with ErdPy and Erd.js? Let's look at our baseline. And our baseline cost is an individual transaction on the web wallet or in Meyer. These are the information I got here was pulled from the transaction data. And for one transaction, it uses 50,000 gas units, and that calculates out to this number here in EGLD. And one of the tools that I have to help me analyze this is the spreadsheet where I put in my total transactions, my gas used, the gas price, the price of EGLD. And so if you were to make individual transaction calls, you could do that at a rate of 140 transactions per dollar. That's at a current price of EGLD, but your per transaction cost will always be this in EGLD. So, what about smart contracts? Well, in ascending order of gas costs per transaction, I have our transactions listed here. And the cheapest smart contract was this smart contract that performed 1,000 transactions, and at this amount of EGLD right here, this was the gas used. So I made some other calls to the same smart contract repeat function, giving it different values, and this is what the cost was. So there seemed to be a return of value on performing a large amount of transactions at a time, because my most cost-effective transactions were performed with the largest amount of total transactions in the smart contract call. So this is the associated fee per transaction. So let's look at our 1,000 versus our 10, and our per transaction was about 2.5 times higher with only 10 transactions versus 1,000, but yet it was still double the cost at 105,000 gas used for 1,000. I don't think that you're going to get much more than about 5,000 transactions out of one smart contract call, because you will be at your max gas limit at that point. So that's the breakdown of the most expensive transactions. And as you can see, the most expensive single transaction is when you deploy your smart contract. So there you go. In an attempt to perform the most amount of transactions that I can get through, I made another call to my contract that has a transaction repeat function, and I put in the max gas on the network. My function is repeat. It's going to send ExeGold from the contract address to this address here in hex. This is the amount, and this is the hex for 5,000 times. Here was the transaction, and it says we can look at it on the Explorer now. It's ready. This time when I put in the max gas, it didn't use it all. So I guess that was some kind of weird fluke that happened to me the first time. And each one of these, so it's 5 over 1,000 XE gold is what I was sending, and I did that 5,000 times. And here's a list of all those transactions. Let's put in this number here. Let's take gas used. Let's come over to my spreadsheet and say gas used, and 5,000 transactions. That is at a per transaction cost of this number here, which is twice. It's still double what your normal transaction cost, which I just happen to have it right here. So let's go ahead and put this in our spreadsheet here. Let's make another line, and Gas limit was this one here. Total transactions 5,000. Transaction fee. What did they say the transaction fee was? This is what they said the transaction fee is. Okay. And the total gas cost. Where did I go? Oh yeah, over here. Yeah. So yep, that's accurate. So it's half an e-gold, or $75. Came out to 1.5 cents per transaction, 67 transactions per dollar, which and where does that put us? Cost per transaction. Yep, our 5,000 becomes our new cheapest call of the smart contract. Gas used is 521 million, so it's getting up there really close to the most you could do. You could definitely squeeze a few more out of this, and that's the greatest value per transaction, which is still twice as much as individual transaction, using any other method. So that's what it comes down to. That's the number, and that's what you're going to get. The cost of a transaction on a smart contract at best is going to be twice, and sometimes much more than any other method. So there you go.